video documents our trip to Herlev Hospital, where we were instructed on X-rays and their uses for computed tomography and chemotherapy. This is possible through the carefully monitored use of radiation to... First, what is radiation even? Radiation is the release of energy in the form of moving waves or streams of particles. We are constantly surrounded by radiation. Some is low-level radiation, such as that emitted from radios and microwaves, and other has a short wavelength and a high frequency, and therefore emits higher energy radiation such as UV rays, X-rays, and gamma rays. The wavelength is measured from the peak of one oscillation to that of another. These rays make up the electromagnetic spectrum. Later in this video, we will talk about the three other types of radiation called alpha, beta, and gamma radiation. The reason why you will not see alpha and beta radiation on this spectrum is because they are not radiation in the form of waves, but small, charged particles. Gamma, however, is a wave.
Isotopes are atoms that have the same number of protons and electrons, but a different number of neutrons. Many isotopes are radioactive. The radiation they give off is what we call ionization. There are three different types of ionizing radiation, which can be given off by isotopes. These are called alpha, beta, and gamma radiation, alpha being the least penetrating while gamma is the most penetrating. Nevertheless, all three are ionizing radiation. They can knock electrons out of atoms and form charged particles. An isotope can either be stable or unstable. In fact, stable isotopes tend to stay as they are. On the other hand, unstable isotopes change. Whenever an atom of an unstable isotope changes, the outcome is ionizing radiation. Humans don't have a sense which can detect radioactive waves, therefore we have certain machines that do it for us. For example, a Geiger-Müller tube. This invention was invented by Hans Geiger, who brought it to us in 1908. Since then, it has been improved. This instrument is used to detect radiation. When ionizing radiation enters the tube, it ionizes argon gas. The electrons from the argon atoms go to the anode, also known as the positive. The positive argon gas then goes to the cathode, the negative. This causes a current to flow in the circuit. The current is amplified and shown on the counter. Another way of detecting radiation is a photographic film. They are typically worn by radiographers that might be exposed to radiation. If the film is developed and radiation has fallen on it, it appears dark. It is very important that light does not fall onto the film before it is developed. If light has fallen on the film, it will affect the outcome of it. Radiation can be absorbed by substances in its path. For example, alpha radiation travels only a few centimeters in air, beta radiation travels tens of centimeters in air, while gamma radiation travels many meters. All types of radiation become less intense the further the distance from the radioactive material, as the particles or rays become more spread out. As mentioned before, alpha radiation is the least penetrating. It can be stopped or absorbed by a sheet of paper, or even by air. If you hold a Geiger-Müller tube more than a few centimeters from an alpha source, the radiation will not be shown on the counter because it is absorbed by air. Beta radiation can penetrate air and paper. It can be stopped by a thin sheet of aluminium. Just like alpha radiation, they are deflected by electric and magnetic fields. But because beta particles are negative, they are deflected in the opposite direction. Gamma radiation is the most penetrating. Even small levels can penetrate air, paper, or thin metal. Higher levels can only be stopped by many centimeters of lead or many meters of concrete. That's why in many X-ray rooms in hospitals, radiographers have to stand behind glass with lead inside it so they are not exposed to too much radiation. Ionizing radiation is high-energy radiation capable of producing ionization in substances through which it passes. The three types of ionizing radiation are alpha, beta, and gamma. Radiation is dangerous for humankind, therefore we need to protect ourselves by using instruments to detect radiations, such as the Geiger-Müller tube, and protection such as leaded glass in hospitals.
You are exposed to all sorts of radiation almost all the time. Most of this radiation is due to nature. In fact, 87% of radiation is natural. One example of radiation from a natural source could be the sun or just a rock. An example of a man-made radiation source could be the TV. 16% of the radiation that we are mostly exposed to are isotopes in our food and thorium in the atmosphere. 47% is from radon gas. We're affected a lot more by radioactive radon gas indoors than outdoors. This is because radon gas enters buildings from the ground. 13% is from artificial sources, such as medical use. 10% is due to the cosmic radiation from the sun. However, most of it is filtered out by Earth's atmosphere before it reaches the actual planet. The last 14% are from building materials, which emit gamma radiation. A hazard from radiation is radiation sickness. Furthermore, radiation damages the molecules in cells. The ionizing radiations, alpha, beta and gamma, separate the electrons from the atoms, which changes the behavior of the atom and therefore also changes the molecules in the cells. When this happens, however, in bigger doses, it can affect processes going on in the body and make a person extremely sick. Radiation can also affect the skin, which is called radiation burns. An illness caused by radiation is cancer. One of the most important molecules in a cell is the DNA. The DNA carries inherited information from generation to generation. Radiation can mutate the DNA, which may cause an uncontrollable cell division in the body that can result in cancer. Both natural and man-made radiation can be very destructive and harmful to living things. But on the other hand, it can also be helpful. By ionizing the molecules inside a cell, radiation can kill cells. This method is used to kill cancer cells. The amount of radiation used for a patient needs to be very carefully controlled, so the person doesn't feel too sick, since the larger doses of radiation will also take down a lot of other cells. Radiation can additionally be used to sterilize. Sterilization means killing a living thing, in this case bacteria and viruses on medical equipment. Another point where radiation can be useful is for measuring the thickness of a metal plate. This is done by putting a detector on one side of the metal plate and a source of gamma radiation on the other. If the metal plate is thicker, the radiation is filtered more before reaching the detector. If it is thinner, a lot more radiation will approach the detector on the other side. These are only a few examples of when radiation can be useful. Radiation carries blood on its hands, however, it has also saved many lives. Radiation is, for instance, used very much in hospitals.
All in all, without radiation, there would be no life on Earth. Some types of radiation are essential to our survival, like the radiation from the sun, while other types we need to take care and expose ourselves only to small amounts when necessary. We hope you now have a more in-depth knowledge of radiation and how it is used to our advantages and disadvantages, as well as how it is used in the medical field and in our everyday lives. Thank you for watching our documentary.